Hey folks, Prof Psych here. How you all doing? Okay, I've got another video for you here. Firstly, let's remember you can follow Prof Psych for some interesting snippets on Instagram and on YouTube as you're now looking. Okay, today's video, guys, just going to have a quick look at this idea. The two words, experimental design. And when you see this, what does it mean? Particularly these three things: repeated measures, independent groups, and matched pairs. We'll add on to that the concepts of random allocation and, of course, counterbalancing. Okay, so let's have a look at this then, folks. Firstly, the words experimental design. You see them in an exam question, somebody has mentioned them. Please do not confuse them with types of experiment. Previously, we've looked at the idea of field experiments, laboratory experiments, quasi-experiments, and so on. Experimental design does not mean this, okay? Now, experimental design means this. We have selected our sample from our target population, okay? So we now have a sample and we're going to run an experiment, okay? Here, what we have to do is to decide how we will place our participants from our sample into the experimental conditions. Okay, let's think of an example. Okay, I am interested in whether listening to music through noise cancelling headphones helps us learn more or whether it helps us learn less. What's its effect on learning? An interesting experiment to do. Okay, so the words experimental design, when you see them, and particularly those of you who are studying for an A-level, for example, a GCSE, experimental design means you're looking for three possible options, okay? You're looking for the ideas of it. The experimental design will be independent groups, it will be repeated measures, or matched pairs, okay? Let's define them quickly, okay? In independent groups, let's make this the most simple. We have two conditions. For example, listening to music and not listening to music, okay? In independent groups, we take our sample and we split it in half. Half the group are in condition A, listening to music, half are in condition B. They only experience one of those conditions, okay? With repeated measures, we take our sample, we take our participants, same experiment, okay? But here, the participants do both conditions. For example, condition A, listening to music, okay, and they're tested, and then condition B, not listening to music, and they're tested, okay? Matched pairs is different. Matched pairs is where we take our sample, okay, and we test them on key criteria that are important to our study, okay, and we then give them a score or a value for those, okay? What we then do is we match them as a pair, okay, and separate each matched pair into a condition. Now, I'm going to go further than this. I'm going to talk it through a little bit more because this can come up and be given a lot of exam marks in an exam paper, so you've got to be really explicit, okay? By the way, our absolute ideal matched pairs, well, theoretically, might be monozygotic identical twins, because presumably we could match them on lots of key criteria, okay? But let's look at matched pairs in a little bit more detail. So I choose a key characteristics for my particular study. Let's say, for example, well, I'm interested in that study about music and learning. Well, IQ, intelligence, will be an important criteria, because if I don't measure it, if I don't try and control it in some way, maybe people just perform better because of higher intelligence. So matched pairs would do this, okay? I would firstly test the participants on their IQ, on their intelligence, for example. I could add in another criteria like age, but let's keep it simple for the moment. So I've measured my sample for their intelligence. I can now, if you like, rank order them, and I match them. So the two most intelligent I put together as a pair. The next two most intelligent I match as a pair, and so on and so on, okay? Now what I do for every pair is I allocate them to condition A or condition B, okay? If I really want to do that in an effective way, I use random allocation, and we'll talk about that in a minute. Now, what that theoretically done, of course, is really have two groups, condition A and condition B, the two different groups who are going to do each of those conditions are theoretically as closely matched as possible on that criteria, in this case, the example intelligence. Okay? Now, folks, let's have a look at the strengths and weaknesses of these experimental designs, because can we say one is better than the other? Not truly. They have different strengths and weaknesses. Okay? There's an interesting thing here. If we take repeated measures, let's remind ourselves the same participants are going to do both conditions, condition A and condition B. Well, the great thing is there are no participant variables because it's the same people, the same participants in both conditions. However, we need to introduce a couple of new concepts here. We need to look at, well, firstly, we already know about demand characteristics, don't we? Demand characteristics are when the participants are more likely to act unnaturally in an experiment. Maybe because of the please you and screw you effect, maybe because of nervousness, something like that. But let's look at these two new ideas. Now we have order and practice effects. Order effects just means by doing one condition before the other, it might influence the second condition. For example, if there's lots and lots of repeated testing in the first condition, condition A, maybe I get tired or I get bored or I lose my concentration, and therefore when I do condition B and get tested, actually I perform worse. Practice effects is the same idea, but here we always get better. So maybe by doing condition A and being tested, I now understand what the test's about. So when I go into condition B, as the same participant in the next condition, I now get better because I know what to expect in the test. Okay, now interestingly, here's a nice easy little trick. Look, independent groups, it's exactly the opposite. Okay, so we weigh up the strengths against the weaknesses of both. Let's look at matched pairs. Matched pairs, really the strength is that theoretically it makes the groups as equal as possible on key criteria. Fantastic, okay? But it's very time consuming to actually do. We've got to pre-test in advance. We might be testing more than one key criteria, okay? And that can take time. Okay, so we've looked at our three experimental designs: independent groups, repeated measures, matched pairs, when you see the words experimental design. Let's just add to it a little bit, folks. We'll come to this bottom bit in a minute. Random allocation I touched on earlier. Random allocation is, well, if we've got two conditions, okay, and we're talking here about independent groups, how do I place my participants into either of those conditions? Well, random allocation means I can't influence it as the investigator. There cannot be researcher bias. It's the most simple way. Look at the picture, names out of a hat. All my participant names are in the hat. I draw out a name, they go in condition A. I draw out the next, they go in condition B, and so on until all the participants are in either condition. Okay? If it was a big group for random allocation, of course we'd probably use something like a random number generator piece of software that would do that job for us. Now, counterbalancing is a little bit more complex. Counterbalancing is to overcome those practice and order effects that we saw before, okay? And this is when we have a group for repeated measures. Problem with repeated measures, we can get practice and order effects, okay? So, here we have our two conditions, okay? But it's repeated measures, so everybody is going to do, let's go back to my experiment, everyone in condition 1 is going to listen to music and then be tested on the effects of their learning, okay? And the second condition is no music, okay, and be tested, all right? But what I'm going to do now is take my group, all of them are repeated measures, they're going to do both conditions, but I'm going to split them into a group A and a group B, okay? In the first testing, my first batch if you like, group A have the first condition, they listen to music and we test them, okay? Group B, for their first testing, they do the no music and get tested, okay? Now what we do is we swap the groups over, okay? And we have a second testing. Group B, who had no music, now have music. And Group A, who had the condition with listening to music, now have no music. Did I say that the right way around? They swap over. I hope you get me, okay? Now we can say, when we look at our results, if, for example, regardless of which you did first, for example, listening to music made people learn better, more effectively, we can conclude that it was the listening to music that caused that better learning, okay? If we find, however, it was just whichever the group did second, all right, we might say, well, it's not down to listening to music or not. Actually, the result is invalid because it probably demonstrates the practice effect. They just got better because they knew what to expect in the testing. So counterbalancing is a specific tool for trying to overcome practice and order effects. Okay folks, can I remind you, you can follow Prof Psych again on Instagram and Prof Psych on YouTube, okay? More videos to come. I recommend you pause those videos, you write your notes, you go to practice exam questions, you look out for the words experimental design and so on. Okay folks, see you soon. Bye.